before I broke my back. Triathlon would not have been my cup of tea.
Yeah, it's not really mine either. I'm just trying it.
Baseball, tennis, and golf were.
Wait, you play baseball too?
I used to.
Yeah, really.
Yeah, I used to be like a top athlete.
I knew you were really good at tennis. Baseball too. It makes sense.
But I was always, even when I played Division I tennis, I was 6'5", 230.
Yeah.
I'm still a big guy.
Yeah.
You know, that's not.
Can't get long.
That's not
Any
runner.
longer.
Yeah.
You want me to go first, Jonathan?
Sure. That way
Yeah,
you
'cause
can open up your.
I don't believe you actually have it done.
I don't either.
Sure.
Yeah, there was no point in time where distance running was because even tennis, I was a serve and volleyer back when they existed. Nobody's serving volleys anymore.
What's that? I'm sorry.
Serve and volley.
Yep.
Tennis. Nobody does that anymore.
That's what we're supposed to do.
Yeah, but that's I was a serve and volleyer back when they existed.
Yeah.
It's the Goran Ivanisevic days. Patrick Rafter. Can't even play that way anymore. These guys are too athletic to hurt you.
Yeah.
Boom! Something wrong.
See, you didn't do it, did you? You didn't do your presentation.
Oh, come on. Man. What the point? What is in here? Lock it out.
Ooh. Now their presentations are gone. Later. See ya.
See you, bye.
What? Wrong with it? Oh, come on.
Why don't you just download it and then send it over?
Yeah, download it on yours and email it.
We still have time, right?
What? One minute. All right, time you shot it.
Hey Siri, set a timer for 1 minute.
Your timer is set for 1 minute.
You seriously, boss? Okay. Oh my.
I forgot a lot. This is good. Yeah. I forgot a lot. This week is very rough. Yeah, there's no committee out there.
I did not find the specific.
Really?
Yeah. There were two that
Oh yeah,
they were just the sake of writing papers on people like
yeah. You're right.
So having selected different sectors.
You're nice.
Easy time.
Damn. Finally!
Just start presenting.
All right, done. Certainly, go back to my chair and let the Lippman come back.
I'll start laughing.
Okay, sure. Doing that. All right, let's try to do it. I'm gonna laugh his ass out. All right.
Alright, I'll stop the timer. Oh, you had 55 seconds left.
55 seconds left. All right, then your turn, Jonathan.
Alright, thank you.
I'm done.
All right, that's fine.
All right, so my research paper, my today's algorithm, I'm gonna talk about the LDI algorithm for high dimensional data. So in the research paper from Chinese due on October 2000, they
This is a Chinese dude.
yeah.
Paper by a Chinese dude.
His name is Hu Yu Yueyang.
Chinese dude got it.
Right. So so the linear discriminant analysis. So first of all, the algorithm he talking about the technology already exists about linear discriminant analysis. So have been successfully used on dimensionally reduced reduction technology many classification problem. So it's everyone know used on a speed recognition, face recognition, and multimedia information level. So they use that algorithm to make the object to find the project A that maximize the ratio of the between class. Scatter SB again within the class set as SW. So that's algorithm. I just copy it. They have a different thing they call PCA, principal component analysis, used to project image from original space into the face of space, where dimensional reduce and I don't know why is this problem there. No longer degenerate the SW small thing is over here. So it can be low defined phase image like size 64 by 64 and 4096 is by 4096 megabyte. So they creating new thing called the direct LDA solution. So basically is have some reduces doesn't they will combine both of them into one to make the more look for the face, and basically they use for face recognition experience for those projects. In another face ID research on the paper that I look at it from Apple. So everyone have an iPhone. Everyone know they have a face recognition for the passcode. Not for the passcode. They look at your face authentication by true depth camera by scanning tons of pixel. Even though your pimple in your face that can be recognized. Don't look at me like that, dude. So they have pretty well done about Face ID for the technology. They have they can be replaced the password though, but they don't on the future. Whenever they turn off the phone, turn on the phone, they need something to verify that is you instead of using biometric. But in the past of the year, they have failed for 3D face, and the box holes is found by the Vietnamese guys. They basically make the fake 3D face and apply the picture on the 3D face. Make bypass the camera true depth from Apple. So the Face ID from the iPhone X and iPhone 8, I think. So everything is device have just been turned on or restarted. It have to be required for the password. The passcode is used for 156 hours, I believe. And everything that you can use a Face ID to verify biometric, that is you. And basically, I do researches because there are lots of behind algorithm that running to scan your picture. One the other function, that pretty cool thing that you can use Face ID to use Apple Pay. Basically, biometric, that is you, so you can withdraw money from your wallets and stuff. I think this feature is it's gonna be useful a lot. And the other thing, Iris from Samsung, the scanning the eyes is pretty good idea too. Running a lot of scanning check for your eyes and stuff. So the second algorithm that I do research is learning machine thing. The learning machine is basically the agent. It's like the machine that mimic 100% mimic at like human like. So they obviously, I think they have a sensor and environment, so the agent will be catch up and will be understand something and remodeling. Like you can go to eBay and Amazon to purchase the stuff or something. They will remind it that you look at for the tire, and then next time when you lock it back, they give you different tire. Recommend oh, you're finding this, so next time we have different thing for you. That pretty good. That pretty cool idea. The learning machine is have too many tape learning machine. It's kind of have like for tape supervised learning, unsupervised reinforced learning, recommender system. And I read the article say the supervised learning is basically the example for the data sets for the house is like the price and stuff. It will be correct the price when you're searching the house price. It's supervised for algorithm to produce more when you want to search. That's how and how much the price is going to be, how going to max. So the unsupervised is like one of example is Google News, like news, google.com, group of news story and web, put them into collective news story. So it keeps sending you is the phone it right now use the news is I think the Google Chrome, they have that function on the phone too. So the reinforced learning is kind of reward for correct output, penalty for wrong output. Learning different from supervised learning problem, correct output and input for something. Recommend is like recommend you something. It's like product from Amazon. Like you buy something, they recommend you the new thing that I'm just talking. Another article that I do research is interesting me a lot is blockchain. The article not talking a lot about a new technology going to be working, but they talking about the blockchain and how blockchain working, how specific blockchain working and Bitcoin working. But now he just remodeling at the learning machine into the blockchain. So the machine is in the blockchain, just like every time the new block is verification, you have to go to the failed transaction. If it's failed transaction, it will be turn the block away. But if it's like the blocks is not failed, it's a further releases for the mining. But now the guy is inventors like one is intelligent software agent learning machine that will be checking the block for not double spending. So whenever the blocks is released, it's go to the intelligent software agent. If it's failed, it's turn the block away. If it's not failing, the block is released. So this is will be help on the feature for the double spending money. Like the seller will be keep the good, and the money is transferred, and the seller doesn't send them the item like that. Also, so the idea paper on the next week, I really want to do the research, but after I talked to Dr. Littman, the way of the feature is not getting there, so we couldn't. But I couldn't do research. But maybe I do the research on different thing for finding some idea to do research. But my research on next week, I want to do something, the robot teaching or something, because I do find some article online already say artificial intelligence and education. So that can be helpful for tutoring, personal learning, testing, automating tasks. But the thing is, I want to have something that can teaching student on put the learning machine to the heart something and teach the students something that they don't understand. But maybe this is gonna be for the future. We're not getting there yet, but I want to do something that the learning machine that can be turned into the robot, and when they see all the chess player, then the learning machine will be learning from the chess player for the algorithm, and then the learning machine will be playing chess itself without the hard coding. For that's his idea paper on next week, and I want to do research about it. It interesting me about the learning machine. So basically, it will be look at you playing chess. Every algorithm learning you from playing chess, like baby to adult, and then getting there, the robot or learning machine can play chess with you like normal human without the hard code, like playing hard, and then they find a way to win you or something. So that is my idea paper on next week. Any question?
So if you were to describe an example of a problem that could be solved using machine learning today, what would you say? Because based on your current understanding of machine learning, what do you think is something that it could be used to solve today?
There's a lot of things can be solved today. Like I don't know, when I do lots of research about learning machine, they can mimic the human. Like I saw the article say they put one robot for learning math and stuff to teaching the high school student for basic linear classify, say the perception and possibly winnow frequent set and association rule mining. So they already have that in the learning machine, but the learning machine is right now they use a lot for the Amazon, Google, Microsoft. The Amazon, they use a learning machine to solve sort the inventory, moving inventory, recognize the inventory. It's all or not all, it's good and not good. So they do all that right now for the Amazon. That's what I do research.
Okay.
But in the future, I think the idea that I talking with you on the restaurant, the Vietnamese restaurant, I think it's getting there, not too high, because you just put one robot on the back, and then you just teaching robot will memorize, or we can reprogramming the robot. If
Right, you have to start somewhere. In order to, that's not happening anytime soon, where you just throw a robot in the back of a classroom and he learns. So what I encourage you to do is pick a more practical problem that is currently solvable, and try to understand how does machine learning allow you to solve that problem.
Yeah, that's
That
why.
then gives you a starting point for, where understanding where we are today and where we can get. I mean, I think we're probably 10 to 20 years away from having a robot sitting in a classroom and taking notes for you effectively, right?
Yeah.
I don't think that's something that's happening anytime super soon. It's not that we don't have the individual tools to accomplish this. We just don't have an entire system put together. So I think for you, given a week's time, it's going to make a lot more sense for you to focus in on a much smaller machine learning problem, looking at various data sets and pulling information out. There's a kind of a buzz phrase you might look up called data mining, which is kind of a predecessor to machine learning. Machine learning is more of a generalistic term now, where it's like, oh yeah, we have all these different APIs that we can apply to just all sorts of problems that could benefit from artificial intelligence, whatever that means. Where in the early days, this idea of data mining was kind of used by a lot of stores and things like that to decide what coupons they should come out with. And how to arrange the store. So for instance, the joke that's in a lot of the data mining books is that the beer is often near the diapers. People who buy diapers also tend to buy beer. It was like a funny truth, but that was something that came out of data mining, where they looked at all of this, something called big data, these giant data sets of purchases that were made across all Walmarts in the entire country, let's say. And they start trying to draw conclusions about shopping habits that a human being couldn't necessarily pick out of there. But a machine that's able to look at so many data points at once or so quickly can start coming up with things that are related to each other. So try to pick a smaller problem like that you find is interesting. I didn't think that they could use machine learning to solve that. So identify some problem they're using machine learning to solve today. Learn about that, how they're doing it, and then maybe propose what might make sense next. If machine learning was to just stretch out just a little bit, 5 feet in front of where its current reach is, what might that look like? Okay, where this robot in the back of the classroom is more like the 50,000 mile reach.
Yeah, because the other thing is I just do the machine learning yesterday when you give me an idea about the learning machine. So I just do research about yesterday until now. It took me a lot of cram on my head. I do a lot of paper research last week, but I turned it out because some of the research paper I kind of don't like it and I don't understand it much. Sure. When I do the research about learning machine, I like it. Then I understand a lot about learning machine.
Yeah, that's what I'm getting at. That's why I want you to pick some small topic.
Yeah.
That way you can wrap your mind around what it can actually be used for, a practical use for it that works today, right? And that'll give you a better foundation for, how machine learning could then be applied to other problems. It really is a very, kind of generalistic term now. We say machine learning for all sorts of stuff, whether it really is machine learning or not.
It could be. I will do research about next week. It could be the learning machine, including the Face ID to recognize the person to unlock the door or something. Because you can. I mean, if you're familiar to the school, like you meeting Dr. Locklear instantly, and he know you are Dr. Littman, and you know him as Dr. Locklear, and you allow go to the data room or something, you're allowed to go to private room or something. But now we have the AI, smart AI. We can learn people and know each other by recognize the face.
Okay,
and
so
stuff.
then take that to the more general approach of how can machine learning be used for facial recognition?
Yes.
How is that system trained? What are the data points that that are required for an artificial intelligence to be able to pinpoint whether somebody is probably the person you're thinking about? That type of thing.
Yes.
So look at it as a generic case, not something very, very specific. Because you won't be able to find much data on something very specific.
Yeah.
But if you ask the question, well, how can machine learning help me identify somebody out of a crowd, something like that. Then all of a sudden you can start thinking about, well, how do we maybe use video footage to pull out all sorts of data points about the faces that we're currently seeing in a picture
Yeah.
and compare that against a giant data set of all people that we have in our database, and then how do we actually compare those, and how does machine learning help us do that rather than us write some sort of algorithm that just searches through data.
Yeah.
You know, that'll help you understand where a traditional programming algorithm ends and where a machine learning based approach begins.
Yeah.
Because they're not competitors. Some of them will work, some algorithms will work better as a machine learning approach, where other ones will work better as a deterministic approach where you just write software that solves the problem and you just use horsepower to do it.
Yeah.
Make sense?
Makes sense.
All right.
Ooh, right.
Next. See, at the end of the day, there's all sorts of problems that human beings are very good at solving, and it's very difficult for us to think about how we would write software to solve that same problem.
Yeah.
With machine learning, now we can start solving problems using computers by telling a computer to think more like a human, rather than us write an algorithm to make a computer act like a computer.
I'm gonna write Jonathan in the future. Work like Jonathan. Having the most heartbeat structure.
About their runs, maybe 75% of the time.
So your votes in the
hello.
working structures.
Yeah, so I wonder how to put it there.
All right,
Yeah.
go ahead.
Yeah, today's my first topic is fair and transparent blockchain based tendering framework. So this blockchain this smart blockchain based technology will help us to create a fair tendering process, fair government tendering process. So I'm not sure much about US, but in many developing countries, there is a big problem of corruption in awarding government contracts because there is no proper transparency. The bidding process gets changed. The terms of the tender gets changed in between. There are many problems. There's a lot of corruption involved in it. So this technology will help to eliminate such practices. So and it also helps something called as open government initiative, where citizens can so there is a lot of there will be openness in the government transactions, so citizens, anyone can check, can verify the whatever is happening in the government. So the tendering process, in any tendering process should have should have some follow some guidelines so that it is not, so that any mispractices don't happen in that. So first is the whatever the tendering organization, once it creates the tender, it should not and it waits for the bidding. It should not change the tendering terms in between, and each of the bidders, interested bidders, can get interested bidders can submit their proposals, and whatever the bid submitted should be confidential. Should be confidential, and once the result is, and in between the bid, the tender process should not change. So these are some certain guidelines which should be followed in the tendering process. So blockchain technology with the help of smart contracts can help us to achieve this. So in a tendering process, if a government want to award some contract, some construction contract or something to any interested bidders, it can generate that tendering process as a smart contract and put on the blockchain, and that tendering process organize what government or any organization, they can sign their transaction with their with their certificate, public certificate. Once that is done and it is put on the blockchain, and now the bidders, who are the bidders, interested bidders, can see that if they are interested to go for that whatever the tender, they can publish their bids. So while publishing the bids, as it should be confidential, because if something is published to blockchain, anyone can see anyone can see it. So as it should be confidential, they can encrypt it, and then they can encrypt that system, and they can publish the contract. And this will be there for and anyone can bid till the end of the tendering process. Once the end of the tendering process is done, time is over, they can give their private key. Individual bidders can give their private key to the tendering organization. So the tendering organization can, with the help of that, they can decrypt their bids and see whichever is and they can evaluate their bids, and then can give the result, like they can give the contract to whichever the organization, and what and it can share the keys of individual bids to everyone. So this all these transactions will be on the blockchain, so it can be verified anytime by anyone. So this ensures transparency. So my next topic is artificial intelligence in healthcare. So this paper speaks about the use of artificial intelligence, how we can use artificial intelligence to analyze the vast amount of data in healthcare industry. So we have different kinds of data, like structured and unstructured. So structured data can be analyzed with the help of machine learning, and which are the unstructured data, like say medical notes or whatever things, that can be analyzed by natural language processing, and which in turn can convert into a structured data. And that once it converted to a structured data, say machine learning algorithm, we can use machine learning algorithms to analyze the thing. And also even now artificial intelligence is being used to diagnose various diseases, like so this is some graph given here, like these are the different in the research of these different diseases, artificial intelligence is involved. Like these are the different journals written all over the world, medical journals. So artificial intelligence is being used heavily. And the paper points about IBM Watson, which can it claims that it gives 99% of the recommendations, which is incoherent with what physicians give. So that's a good. It also points out some of the challenges in the current day healthcare industry to use AI. The biggest challenge is there is no proper legal framework. Say if AI gives some incorrect decision, who will be responsible for that, and how to use the customer's data. So there is no proper legal framework. And another thing is there is no proper data exchange. There is no motivation for data exchange in the healthcare industry. It points out few of the current day challenges. Next topic is AR microscope for real-time automated detection of cancer. So this is a paper published by Google. So in cancer treatment, optical microscope is used to analyze the tissues to find that is useful to find the tumor, like the count of cancer cells, and there are many other details which should be analyzed. So this entire process is tedious, and it is time consuming and tedious and time consuming. So so researchers have developed with this AR Microsoft, they are doing two things. One is they have integrated artificial intelligence as well as into the system, as well as uh, augmented reality. So they want to use augmented reality to superimpose whatever the results get from the from the artificial intelligence system, whatever the results in the real time, they want to superimpose to on the real specimen which is being understudied. So whenever in the pathology pathology study the tissues, so they can get the real time information and say this particular portion of the specimen there is cancer cell, so they can get real time information. So this technology is already present, but it requires additional scanners. It is expensive, so Google has made it everything. It is made a low cost technology. To demonstrate the application, Google has trained their algorithms by two different kinds of cancers. I forgot their names. Two different kinds of cancers, and it claims that they have got good results with this. My next topic is conceptual captions. So this is another paper by Google. So Google has created a data set consisting of images with captions. So it wants to use this data set for training any machine learning algorithm for automatically captioning an image. So what are the use cases of captioning? Captioning really helps the people visually impaired. So one practical example is it helps visually impaired people who cannot see a visual information. We can get the caption of it, and that caption can be converted from text to speech with text to speech conversion software, so that that can be communicated with them in that way. So it wants to first Google in this particular paper focus only on the creation of data sets. Google has created a data set which has 3 million images with a caption. So this entire process is done with without manual intervention. So Google has it has scanned over 1 billion web pages which have and scanned 5 billion potential images. So in each alt tag of alt HTML tag of that image element is looked for. Now every image will not have alt tag. There are only some percentages of images will have the alt tag, and there is it used some filtering criteria that image should have so and so quality. It allows only good quality images, and the images which are inappropriate are removed from them. And there is also text based criteria that each caption each text collected from the alt tag, it looks for the unique only the captions which contain some unique word or if it finds some tokens in that caption which it finds in the dictionary with the dictionary of words, only those things are collected. So at the end they got 3 million good images. So these images have been it has used these images to train their machine learning models, which can be helped to caption an image. So they have compared this with another competing product or competing data set, that is Microsoft Cocoa. So it's actually Microsoft and some other team. It's they have been combined this. So that this is not, this is MS Coco is that they have their data set has just 10 times less images when compared to Google's one. The reason being is they have used manual captions, manual captions. So they can't scale, they could not scale it like what Google has done, and they've used these two data sets and tested a couple of different machine learning algorithms, and in the two cases this conceptual caption data, Google's dataset has outperformed Microsoft, even though Microsoft dataset image caption quality is slightly better than the Google's one, but since they have very less number of 10 times less number of images in their dataset, so Google, even with the lesser quality captions, has outperformed slightly outperformed this Microsoft Go. My next topic is machine learning behind Android's Smart Linkify. Google has released, this is again paper by Google. Google has released a Smart Linkify into all into Android devices. They have released, so it can detect some context in the text, and if you have some mobile number or address, if it thinks some part of text is an address, so it gives a linkable text. So if you tap on it, it gives it opens map app, or if it's a phone number, it opens a caller app. So this paper tells how this is done, what is the machine learning algorithm, the technique underneath it, and Google has made this as an open source API. It is called Text Classifier Android API. So in this system, it has two neural networks. First one deals with, so in the first one, the individual, whatever the text is broken into, text is separated by words. Obviously, it considers a word as a which separated by the text, and it generates all the subsequences of the words with say certain maximum length, say 15 or 20, certain maximum length. So in this picture, you can see this, and we can have multiple subsequences, and then call 857, 555, and so on, different subsequences. And after finding these subsequences, it is rated by the it is called scoring neural net. First stage is called scoring neural net. That will give different scores to each subsequence. In this section, you can see for this 857, this mobile number, it considers its neural classifier consider it as a high weightage one, because it sees that it is a 10-digit number. It could be a mobile finite things, and it gives high weightage to it and lesser weightage to the other. And once this is done, all the mapping ones are removed. See, only and, so in the next image you can see only the mobile number, this is and are there. Remaining all overlapping things are removed here, because they are not considered as a as to some entity. And now the classifier in the second stage, this all classification neural net, it will decide whether that is among these two and that number, which is the entity. So neural network will decide this as the phone number. Again, it is not this simple. It should also think about the context, because it's not that any 10-digit number is a mobile number. It could be some other thing in some other context. So Google has trained this model with the TensorFlow. They have the, TensorFlow is a Google Shape API, machine learning API. So it has used that API, and it has used data from different sources to train this model, so that it understands the context also. So, yeah, this is mine.
So tell me about TensorFlow and why it seems like this was implemented using TensorFlow, but did you get too much into how TensorFlow differentiates itself from other machine learning platforms?
No, I did not.
Okay, yeah, I thought that would help Van a bit, looking at machine learning stuff. The one that intrigued me the most out of these was the augmented reality for cancer stuff. So help me understand, how is the idea that the vision is actually better with the cameras than somebody looking under a microscope? Or is the microscope the feed into the augmented reality system?
No. Can you repeat the question?
Okay, so, well, why don't you explain to me how you perceive the augmented reality works for exploring potential cancer in patients? Because I'm kind of envisioning, typically with augmented reality, you're using your phone or something, or using a headset, and you're kind of holding it up. Well, I mean, if you're dealing with cancer cells, they're tiny.
No, it displays some whatever. There are two things here: artificial intelligence and augmented reality. Artificial intelligence will find the patterns of the tumor cancer cells,
right.
and will say. So it gives the result to the AR system. To the computer.
So
will
where is
capture.
the AR system?
AR is another screen that we can. It has another
Okay.
AR system connected to this microscope.
Gotcha. Okay, so the vision is the microscope.
Yeah.
Then there's an AI that tries to determine what it's looking at.
Yes.
And then the augmented reality gives you kind of heads up information about what you're looking at.
On top of the specimen, real specimen, it displays the virtual thing.
Got it. Yeah. That one's cool. Because one thing I always struggle with is coming up with like valid uses for augmented reality. Like on paper, it sounds like it should be cool. Yeah. But I don't know. It's like hard to come up with stuff that
are useful.
That AR is useful for, right?
It is good for fun.
Well, I mean, I was trying to think about it like just, from, I guess, my world, like as a golfer, on one hand, augmented reality kind of sounds like it would be cool from the perspective of if you wear these special glasses, I'm out in the golf course and I can kind of just look up and maybe there's a, big sand trap over there on the left and I can kind of look at it and it'll tell me, oh, that's 225 yards out. So in very much real time, I can kind of look around the course and it'll kind of give me an idea how far something is, saving me time for, pulling out my laser scope thing and, scoping the sand trap or something like that. But even then, it's like, well, how accurate is it? How much battery life are you going to have? It's cool for 5 minutes, but then is it just more in the way? You got this whole thing in your visual field.
Well, it has to be supports in the graph field have to have a camera.
Not necessarily, because I mean, the systems that do exist now, they overlay on top of like a GPS app.
Okay.
So you already have a GPS app that knows the distance to different things. Now it's just saying, you're looking at a bunker or something. But this was pretty interesting where it's taking something that, a really high precision instrument, like the microscope, and saying, well, a human can look at this and make a decision of what they think they're looking at. With machine learning, we can enhance that accuracy. So, maybe between the human and between the machine learning, especially if they're agreeing what they're looking at, that adds a higher likelihood of success or something. And then the augmented reality part is kind of marking up the real-time data that allows the human to further, read what they're seeing. Yeah. So that seems like a pretty cool thing to me, at least, like a reasonable use of AR. All right, and what are you looking at for next week?
Smart contracts.
So not that.
So
I do like smart contracts.
Different application.
Yeah, smart contracts is kind of what made Ethereum cool.
Yeah.
So, okay. All right, good. Cool, buddy. That popped up TensorFlow while you were going. I was reading about, we should use that for the hackathon. Which one? TensorFlow. So everybody in here is doing the hackathon?
Yes, sir. You're supposed to sign up already.
On Monday? There is some.
Yeah, I'm gonna do a it's not this Monday, it's the Monday. Next Monday, yeah. There's going to be like a boot camp in here, probably 6 to 8 p.m. or something like that, 6 to 9 p.m., where whatever machine learning platform we pick, I'll give a boot camp crash course kind of on that. So I'm looking at TensorFlow. I want to do either IBM Watson, TensorFlow, because it's Google, and or Amazon ML. Something from a big company. But I'll look into the TensorFlow. That's Python based, and I think that maybe opens it up to the biggest audience, because that means that our, earlier programming students who have had 200 are familiar with Python. So lots of people will have access to it that might be accessible. So I'll look into that. All right.
All right.
Yeah.
So the first article that I looked into is called Fast and Deterministic Constant Factor Approximation Algorithms for LCS Imply New Circuit Lower Bounds.
That's a dissertation.
Yeah, and I didn't understand a darn word in this entire paper.
That's the point.
So what I got from the paper was that it uses the longest common subsequence in the world of bioinformatics and text analysis. So it basically is talking about the fundamental similarity between two strings, but the classical way of the programming algorithm that computes this doesn't allow for the computation of long strings. So they were trying to use distributed PCP frameworks to replace the hardness approximation factor with a super constant factor. Again, no idea what that means. And then they were really proud of the fact that they were finding new lower bounds in this, but again, I couldn't understand what they were talking about. The paper was filled with various theorems, lemmas, and proofs, which made me want to cry. So I didn't try too hard with this paper to understand it because I thought it was kind of a lost cause no matter how many times I read it, but I tried. My second one was called Fault Diagnosis of Wind Turbine Structures Using Decision Tree Learning Algorithms with Big Data. So basically, this article decided to use decision tree learning algorithms to kind of automate a way of determining wind turbine function. So it would detect faults, errors, damage patterns, anomalies, and abnormal operations. And they chose the decision tree learning because it was easily assimilated and interpreted by people. They also thought it would be a good way to predict unknown outcomes. So ideally, they were using this decision tree algorithm to they used 48 turbines in this thing, and then they extract different paths linking various vibrations to whatever their root causes were. So imagine you have a wind turbine, a vibration of sorts might not be ideal for that. So they were taking all the statistical data from that and plugging it into different algorithms to determine what the causes were of it, and then they were positive in the direction that engineers could use this to design replica simulations and then try to find solutions to the problems that they might not even know that they have. So for this article, reading it wise, it was a little bit easier to follow because it had the real life application. But it did have a ton of algorithms in it that I didn't quite understand, a ton of equations in it that I didn't quite understand. But it was interesting I guess I never would have thought of applying this to wind turbines in the first place. My next article is called "A New Penalty-Based Wrapper Fitness Function for Feature Subset Selection with Evolutionary Algorithms." So the feature subset selection is a pre-processing task used in data mining and pattern recognition. And basically, they created this new fitness function that applies a penalty term for high number of features. And it was to see if they could get better classification without degrading the accuracy of the process. They used a variety of different evolutionary algorithms, and I could list them off, but you probably wouldn't know what they meant anyway. So basically they were trying to add certain classification accuracy to this. So they were trying to retain characteristics and discriminatory information, and then eliminate redundant or irrelevant information. And then they found that their proposed function was effective in reducing the number of features down without actually taking away any of the accuracy. Somewhat difficult to understand, way easier to follow than the first paper I read, but I still didn't quite grasp the concept of it. My next paper is called Machine Learning-Based Big Data Processing Framework for Cancer Diagnosis Using Hidden Markov Model and GM Clustering. So basically, they're working with genetic mutations in genomes. Excuse me. They decided to use this Markov model with Gaussian mixture clustering, and it's basically to model the DNA copy number change across the genome. So this DNA copy number change is associated with genetic mutations, and it can be used to not only diagnose cancer, but it can be used with other diseases in figuring out the progression of it, or estimating certain things regarding it. Their proposed model gave a scalable machine learning approach to overcome any issues that they have in copy change detection. In recent years, the genomic lengths have become too long to process the way that they have been processing them. So this was their proposed model to kind of combat that. And they found their experimental results were effective in this, but they still had a little ways to go in their research with it. The article, oddly enough, had quite a few grammatical errors, so it's kind of hard to follow. A lot of equations and a lot of acronyms. I think they turned almost everything into an acronym, so there were like 3 or 4 per sentence, so it was a lot of going back to the beginning and figuring out what the acronyms meant in order to follow it. And my last paper was a big data classification approach using LDA with an enhanced SVM method for ECG signals and cloud computing. So the ECG signals are electrocardiographic signals. They use it to identify and classify different heart levels, different heartbeats. They break it down into 4 different heartbeat levels, a left bundle branch, a right bundle branch, a premature ventricular contraction, and a premature atrial contraction. However, with these ECG signals, there's a lot of noise, kind of like static in the radio, that interfere with it. So it's less clear to read, so it could lead for some ambiguity with it. So they proposed this SVM model, a support vector machine model, that used a weighted kernel function method to classify these features in a more pronounced way. So this new model cuts down on noise. It identifies the Q, R, and S waves more so than they would originally in other models, which basically just reads to a clearer output of it. The technical information in this regarding the ECG itself was a little bit hard to follow, but I thought it was a really interesting read. And I think it's, I guess I didn't realize there were so many problems regarding electrocardiographs to begin with that they would need this, but I thought it was interesting that they thought to make it clear in the first place. Again, they said they wanted to go further into the research with it and get it into some sort of cloud computing, but they didn't say how they wanted to do it. That was kind of thrown in at the last minute. My next slide just says what I want to work on for next week, and it was the machine learning for cancer diagnosis, to look into either if they have more research on that or much more research applying algorithms and machine learning to any kind of disease diagnosis.
Was that the evolutionary algorithm one?
That was the Markov model.
Okay. And what was interesting in this last one, the ECG thing, I'm trying to remember if that's the, so recently Apple announced their newest Apple Watch, right? A couple months ago or something like that. Like, is it ECG that it has built into it where it like automatically detects when you're having heart problems? Or is it,
I don't.
EKG, yeah.
is it EKG or ECG?
ECG and then they do the same.
Yeah, so it has, I mean, so basically it has I mean, I'm guessing it's based on machine learning. So it built into the watch, it's taking constant data or something like that, and will tell you whether or not you're about to kick the bucket and need to get somewhere. So just kind of, you know, that stood out for me because I know that's something that I think you're going to see in like wearable technology relatively soon. And if they're trying to get better and better and better readings by getting this data up in the cloud, then all of a sudden you could take a small device that just has the sensor, and as long as it's internet connected, it can do a lot of the stuff cloud-based, where I assume you'd have a lot more accuracy for a wider range of data as opposed to what you can squeeze onto the watch in terms of data storage and stuff like that. So kind of made me think about that. I don't, let me look it up real quick.
I'll keep that in mind. If I can't find anything on the other one, I can switch it to that.
Apple Watch ECG. I really thought it was ECG. Yeah, ECG. I'm seeing ECG. Apple Watch Series 4 features ECG on your wrist. Low and high heart rate notifications, fall detection, emergency SOS, a new breath watch mode. Yeah, so it has ECG built onto your wrist. Yeah, interesting. But apparently, let's see, okay, here's another thing. It says, can Apple Watch do EKG?
What to do is Apple Pay.
Yeah, I'm seeing EKG.
Both actually.
It does both?
I mean, one article.
Interesting. Yes, I wish I had that on like an Amazon, or an Android-based watch. I don't have anything against the Apple Watches. I had one for a while, but since I switched to Android, it's not going to help me.
EKG. You mean like just like the heart rate monitor or the?
Well, yeah, like the detection stuff. You know, like I want it to scream at me and say if I'm having a medical emergency. Like,
yeah,
you know.
I think the Phoenix does that Garmin.
Well, maybe too late then.
Well, no.
Oh, yeah. I think the idea is it's supposed to catch it like early. Like, you know, you might know 5 minutes later when, you know, it's hit the fan. But, you know, maybe there's like those early signs when, you know, you're starting to have some kind of weird situation when, you know, the reality hasn't caught up to, you know, you keeling over.
I'll look into it. I think the Garmin Phoenix 3 has that, but it's also kind of expensive.
Well, if it actually has it, I mean, I don't care about the cost.
True, that's fair. I care about the cost.
Well, I mean, even just, regardless, even just from a health perspective, right?
Yeah.
I mean, you know, it doesn't, if something legitimately is going to benefit your health, it doesn't necessarily matter what it costs at the end of the day. It's just being a big guy who does quite a bit of sports in a body that probably wasn't really built for doing that much sports still. It wouldn't be a bad idea for me to have some early detection stuff on me.
Yeah, no, absolutely. Yeah.
Might be a benefit.
I think it was Steve Taylor was actually telling me, he had his Apple Watch on and they were talking about something in a meeting and his his watch started buzzing, like going off crazy because his heart rate was getting so high because he was sitting there, but his heart rate was getting really high. So the Apple Watch just started triggering, like, you need to go do some, do you want me to call medical support or something?
Defibrillator.
Yeah, right. Now we're talking.
Firing back.
All right. So my presentation's on algorithms. Interesting. All right. So this first one this was a shorter article, but it was kind of thought it was cool. It was a cancer face-off contest. There was a nonprofit organization. Well, actually, okay, no, the Cancer Center in New York offered this multi-million-dollar prize to anybody who could come up with cancer vaccine, and essentially, I think it was with using algorithms or something like that. In this, the algorithms were used to find a personalized vaccine for a patient who has been diagnosed with cancer. These two nonprofit organizations took a variety of different computers, ones with different power, focused on different things, and they ran all these algorithms. They just cranked them out, had them cranking, to see if they could come up with essentially a vaccine personalized to that patient. The goal was to use the tumor's DNA to detect or predict what mutations would be addressed. So essentially, finding which bits of the mutated proteins would be detected by a T cell. And you can correct me on this because I have no clue what I'm talking about. But that's how they were detecting it, because that's, I think, a vital part within the finding cancer. By the proteins that mutate are correlated with the cancer and how to treat it. So if they were using different algorithms to predict this, then they could better treat the cancer or detect it earlier too.
Custom treatment.
Custom treatment, because the whole idea there is they're like the cancer is different for each person. So we're maybe not going to find a vaccine that's going to work for every single person. But if we can come up with an algorithm that can predict or learning for each patient, and it'll come up with a specialized vaccine for that person. So
prove the effectiveness for that.
Right.
Cool.
Yeah. Okay. Next article was machine learning algorithms to predict therapeutic outcomes in depression. I thought this one was really cool because in my job I see a lot of depression or anxiety or things like that, and so I was like, okay, now we're kind of merging my two worlds that I've got going on here. So this one was cool. They actually had to do a lot of studies to determine what therapeutic responses would be ideal to benefit a depressed group of people or patients. So they had to look at I think they had to look at current responses that we have to patients in clinical settings. And I think they used the different types of interventions that they used or looked at were neuroimaging, phenomenological, genetic, and then combinations of these. So then they developed algorithms for each of these factors and then different combinations of these as well. So with that, they were actually able to come up with an 82% success rate for giving validity to the outcomes for the algorithms used in that. So this is really interesting that they could, they have a patient, they enter in what they're going through, and they can figure out, okay, this is the better response, or this is the type of response I need to give to this patient based upon what they're going through, or something like that. So yeah, I guess 82% is pretty high if we're looking at like what's a good response for it. So yeah. All right. The next one, we looked at algorithms used to predict crash risk from glance patterns in naturalistic driving. So depending upon how I'm driving down the road and I like glance over my phone, or how many times I'm glancing, they're looking at my glance patterns to see how likely I'm going to crash. So this is more of just kind of informative, and then also to look at how do we need to build cars and the architecture of the cars to make that not happen? Because if it's like duration, distance, or time of the glance, then how are we going to design a car so that maybe people aren't looking as far to glance off the road or something, so that way they don't crash? So they came up with 24 different algorithms. They didn't go into depth on all of them, but they kind of range from anything from factors that include the frequency of glances to the duration of glances to the distance of the glances from the roads, kind of what I was talking about. And actually the most accurate algorithms they found used was the time of glances. So if I'm like, rather than like the number of times I glance over, as long as I'm coming back to the road quick, that was okay. But if I'm looking at something for a long time, or even if it's like I'm just looking at my dashboard for a long time, not the distance, it was more of the the time that I'm glancing off the road, which kind of makes sense. We can guess that would make a lot of sense, but essentially the algorithms back that theory up. So it's kind of like this was they looked at a lot of data from this. I think they had 100 cars and drivers, that they were looking at. So.
Is this like do they give you any sort of warning, or are they really just kind of measuring like the effectiveness of a driver?
Effectiveness of a driver. I think they were
how crash prone somebody is.
Right, and I think they had the simulators for it. So because I was like trying to figure out like it was kind of the way they worded a lot of these articles, like it kind of was over my head and I couldn't really follow it. So, but to my understanding, they used a simulator for this, and then
so I can see that being something that's kind of interesting for like insurance companies, where you, because I know that what's the company that has
State Farm has, I know, a thing you can put in your car to like.
Yeah, I think Progressive has that too, where they
snapshot. Yeah.
So you plug it in, and it looks at different things your car is doing to see how safe of a driver you are.
Oh yeah.
Take that to that kind of that next level where it's not just your actual car's speed and stuff like that, because you could just be really good at staying between the lines even when you're not paying attention, but actually look at your behavior patterns while you're driving to see, are you a low risk person or are you a high risk person? Because that's insurance is completely based on that.
Yeah.
Health insurance is a perfect example. My wife and I have the same value policy.
Yeah.
Mine costs like 7 times more than hers. Right. On one hand, I'm male, she's female, but on the other hand, I'm a much higher health risk than she is because of other things. Well, in something like this, when you're dealing with motor insurance, somebody who is a very conscientious driver is always keeping their eyes on the road and moves between their mirrors at the right pace and stuff. You could almost teach somebody to be a safer driver just based on data.
Yeah. This is interesting, and this leads me to a completely different point. Now I'm getting off topic. But with all these things that we're adding, like the algorithms to analyze human behavior, it's like we're leaving less room for humans to make error. There's probably more of a pressure on people to think like, okay, now I'm being tracked. Because like if I'm driving and I have something analyzing how I'm driving, I'm going to purposely drive more like cautious, and then I feel like more anxious to make sure that I can't make a mistake or anything like that. Or like, I don't know, other
that
things.
Bad though?
Well, I don't know, because like I think like in my world, I would say like I see a ton more anxiety, like the levels of anxiety and like people going to counseling for are way higher.
The result might be that you train yourself to be safer.
That overall task is
might be that you have increased blood pressure.
There might be more detrimental to their health. Like that overall task may be great, and your insurance rates are lower, but you're gonna die 10 years sooner because your anxiety's gonna.
You got ulcers from your morning.
Right, which is kind of interesting. So, that might be another study.
That's why we need autonomous cars, so it won't matter.
I might look into that. I might change my topic. All right. This one's cool. Estimating avocado sales using machine learning algorithms and weather data. So essentially, they took data from cities all over the U.S. and they looked at when the high markets are, like when people are buying more of them, what type of market, who's buying them, the weather for when they're buying them, just like as much data as possible. Well, they use the machine learning to essentially sort through all this data because one person couldn't do that. The market for avocados has grown, I think, about 16% since 2008. And so like we can't produce enough avocados in the U.S. to serve the whole U.S. So now we have to buy it from other countries. Well, if we could figure out when the optimal time is to ship avocados to certain places or how many, certain stores, certain cities, what parts of the U.S., things like that. We know that this type of weather is more like this, or it's more rainy and cloudy over here in Washington. What does that mean? Anything? Like if we can better understand that, then we can have less waste of the avocados, not as much getting thrown away. We can prices can be driven down, and we don't have to import as many avocados. So this can be used in a lot of different ways, but I just thought it was interesting that they're using it for avocados. So they actually used a support vector machine for regression and multivariate regression prediction model to find this data, and they actually had correlation coefficients of 0.995 and 0.996. So if you don't know what that means, you're trying to get as close to 1 as possible. in these correlation models. So that's really good. There was a really strong correlation between the variables they used. As far as what variables they used, they didn't tell us because that's probably they don't want to tell us because that's they put a lot of money into that. But it was kind of interesting that the highest demand or they have these algorithms to analyze it because as time changes, the algorithm's gonna have to adapt to what the market's doing. So
It always shocks me how much guacamole costs at a restaurant.
so much, it's ridiculous, and it tastes so good. It's like
When you go to a place that's like, you know, $11 for tableside guacamole.
yeah, like what the heck?
You paid $11?
Oh, whatever. I mean, it's just always expensive. Sometimes
Yeah.
it's like whatever.
Or do you want to add avocado to your meal for $4?
Yeah.
Like,
What do you mean avocado for $4?
I mean,
On
like,
my own.
yeah, right. I can go buy like 5 avocados for that. Like, so, and then this one was really over my head. So this is what I gleaned from this. There's 5 separate predictive coding algorithms that they looked at, and they were kind of analyzing how they were similar and different, but I couldn't even figure out what they were doing, so I don't really know how they were similar or different. But what I got was the first algorithms that they were looking at was linear predictive coding in digital signal processing. They were looking at whether it be audio or video, they were looking at how they can predict where the signal is going to go based upon the data that they have. Yeah, and then they want getting into farther, it'll make more sense. But predicting the number 2 was they were predicting signals from the retina in order to dial in on the most important signal coming from the retina and discard the rest. So they have all this data coming in from the retinal nerve, and they wanted to process that, essentially compress it, I think is what they were trying to get at. And so they were trying to trim off any data they didn't need, and then something that they could generalize and put in later, so they didn't have to worry about all these other factors. They were trying to get to the meat of the data coming in. And I think the first algorithm they were looking at had to deal with that, the signal processing. So they were trying to find what's the most important chunk of our data that's coming in, so we don't have massive amounts of it, to my understanding. Predicting the 3 through 5 was all based on the same thing. There's just three different algorithms. So predicting the behavior in the cortex of the brain by looking at the signal coming in from the retina and developing prediction on what the errors will be produced. And it doesn't really make sense, but they were essentially looking at okay, what's happening from the retina to the brain? Okay, here's our signal coming in, and why is the brain reacting the way it is? Are there errors happening in there? Are they predicting? Can they predict that? That's pretty much all I got from it. That was super confusing, but it was really interesting starting out. But then I just kind of got lost in it. So for my topic paper, I had 3 different options, so I'm not really sure which one I'm going to pick yet. One of them was looking at like the supply and demand or models that we have, like how we have the supply of this and we have demand for this. How do we manage all this data all these the product supply and demand that we have? I'm not really sure which chain I would go there, so it's just really interesting to me. So I kind of wanted to leave that as an option. The second one was economics. I want to look at the stock market with prediction algorithms. This is something I want to do for my senior sem a little bit, but I didn't really get the chance to go that in depth because it was more of an informative senior sem rather than a research senior sem. And I wanted to take like Markov chains or stochastic processes essentially and use that to model where the stock market's going to go based upon its previous occurrences, like whether it be a little change up or down, big change, like what's going to cause that next outcome. So I wanted to look into that. I don't think I'll have enough time to get that all into a paper, but at least like get the groundwork for that. Or the other thing was just to look at the U.S. economy and how the economy is influenced, or how much of the economy is influenced by algorithms, or even algorithms are used to calculate things within the U.S. economy. So I think I go a lot of routes that way too. So kind of all over the place. But those were all interesting things to me. So I'll figure out what I'm going to do this weekend.
So why is avocado toast so expensive?
You tell me. That's okay. I think it's is it the cafe just up the road by
First Watch.
It's not First Watch. It's Cafe 1505.
Oh, 1505. Yeah,
1505. That's ridiculous. I think it's $11 for avocado toast there.
Yeah. First Watch has avocado toast as well, and it's like their best seller. And I've had it; it's good.
Yeah.
How much is an avocado?
$1.50
$1.50
at most. Like
and I mean, I'm guessing that on avocado toast, maybe you use one whole avocado, or is it two?
Probably
It's like
half an avocado.
Okay, so if you're going crazy avocado toast, that's a whole avocado, right?
Yeah, we'll say.
So you got $1.50 plus whatever a piece of toast costs.
What else?
We'll say it's fresh baked bread that they made.
Come on, dude.
That's cheap. That's cheaper though.
That's true.
But regardless, I mean, it seems like they'd be pretty profitable at like $6 or $7.
Yeah.
What do they put like smoked salmon?
No,
Not
they put like a
that, but
lemon
they-
juice or a balsamic.
Yeah, there's usually some kind of balsamic mixture, and then maybe some.
Yeah, or sea salt. Don't forget the sea salt.
Yeah, if they just say salt, costs nothing.
No.
Sea salt plus
Boom.
$3. Plus $3, yeah.
Chocolate market went through the roof when they had sea to it.
Where's that restaurant?
Where's that restaurant?
So Cafe 1505, right next to the bank, right next to Zarletti. So BMO
Food's
Harris
good there.
and Zarletti are right there near Metfun.
They call it avocado.
It's avocado toast. It's like kind of a
It's
I don't-
mashed avocado on piece of toast.
yeah
That's it.
for $10, $11, $15, $20,
Totally worth
$8.
It is good.
Labor,
But-
dude.
Labor.
Yeah.
See what they should do. This is what they need to do.
Yeah.
Yeah. So so if you knew the price, if you're the restaurant owner, what you need to do is you need to do something like this. If you're going to charge the $11 for the avocado toast, let's say, what you do is you have the $11 avocado toast, or you have $15 all you can eat avocado toast. You're pretty much you're most of the time going to upsell people to the all you can eat, because there's avocado toast isn't all that filling. People like basically twice the portion for $4 more. They're still making tons of profit. They made $15 off like a couple avocados. Sweet.
But then I also think about the population that probably goes to that cafe. They probably eat avocado toast, one serving of it, and they're full.
Why? I mean, there's like a lot of business meetings and stuff there. Or you think old people?
I'm thinking old people.
I don't see that many old people
Really?
at Cafe 1505.
Every time I've been there.
Well, it's a lost of old people.
Well, everybody seems old to you.
Well,
These are my contemporaries.
I've been there a couple of times. It's old people a lot.
Because I go to First Watch all the time. First Watch,
is good.
we get 20% off.
What?
Concordia gets 20% off at First Watch.
Oh, that's a game changer. That place is good.
I yell at the manager too. I'm good friends with him. I'm literally there 3 times a week, probably.
Really?
I have all sorts of meetings there and
Yeah.
stuff. I didn't find out about the 20% off thing until like maybe 3 months ago. And it started like a year and a half ago.
Oh yeah.
I mean, I bet you it's probably $500 or $600 in discount that I'm out.
They know you are.
Oh yeah.
Then negotiate.
I made him give me like free breakfast. All right, let me stop the recording. So we're good to go for next week.
I think so.
We'll see if we. So which is better? Is the projector better or is the TV better?
Projector.
You think the projector is better than seeing the TV?
TV too heavy.
Well, no. I mean, let's assume it was already here.
Well, as soon as it's already here,